Welcome, Year 10. It is Lesson 6, 1.4, Domestic Electricity. Today we are going to be looking at, amongst other things, the fuse. You have that as a title, and then you have an empty page, do you not? Notice that the fuse has a very, very thin fuse wire moving all the way through. In essence, what happens is this: if too much current flows through that fuse wire melts. It breaks. It breaks the circuit. It's a weak link. There's a reason for that. You want a weak link in the chain. So let's watch a video on this. So we have on the left hand side, you can see a hand that's linked up to the hand is in control of a variable DC power supply. It's a power pack. And then we've got some wires. We've got an ammeter. It's reading 0.57 amps. We've got two crocodile clips. Now at the moment you can't really see it, but it is there. In between the two metal clips, there is a very thin piece of fuse wire. So the circuit is complete at the moment. Let's have a look at this video. Increasing the current. And the wire is heating up now, red hot. And it breaks, and look at the current reading, 0.00. The circuit has been broken. No more current flows. This wire here is the weak link. Too much current flows through it. It heats up. Bang, it melts and no more current flows through the circuit. So I'd like you to write a passage about the fuse. I'm going to try and use some or all of the terms here. So the fuse protects appliances from melting. And it reduces electrical fires and helps to prevent people from becoming electrocuted, getting an electric shock. How does it work? Well, if too much current flows through the circuit, the fuse melts. The fuse is attached to the live or brown wire, and so is the switch. Once the fuse has melted or blown, it has to be replaced. Now you can get fuses with different fuse ratings. 3 amp fuses, 5 amp fuses, 13 amp fuses. A 3 amp fuse will be very thin. A 5 amp fuse will be slightly thicker wire. And a 13 amp fuse will be thicker wire still. Now then, we have here your electricity box, and inside that, mine is under the stairs, you might be next to the front door. You should find out where it is actually. They contain a number of miniature circuit breakers, or MCBs. There are several here, and here is an example of one of those miniature circuit breakers, and you can see at the moment it is off. If you were to turn this lever up that way, it would turn on again. So you can see that this one here has tripped. It is off. Now, if you so wish, you could have a look on YouTube and have a look at MCBs, miniature circuit breakers. It's quite interesting. Now, each miniature circuit breaker will deal with one circuit. So one miniature circuit breaker, and there's one of them there. One of them will deal with all the sockets on a ring main. So that might be all the sockets downstairs, and then you have all the sockets upstairs as well. Then you have another one that deals with all the light switches. Then you have another MCB that deals just with the cooker. And then you'll have another MCB that deals just with an electric shower or immersion heater. So you'll have a number, so they all won't trip at the same time. So, in modern houses, fuses have been replaced in consumer units with miniature circuit breakers, or MCBs. We still have fuses in 3-pin plugs. You want more than one way of making sure that the electricity that you use is safe. Now, they are attached to the live wire as well, just like fuses. And they cause a break in the circuit if too much current flows through it, just like a fuse. However, they don't melt like a fuse. They are an electromagnetic switch that causes two metal contacts to be pulled apart. What are the advantages over normal fuses? Number one, they can be reset. Okay, with a normal fuse, it blows if too much current flows through it, and you have to replace it. This one, you just flick the on-off button, so they can be reset. And number two, they are more sensitive to a change in current and switch off more quickly. Okay? Right. You will have socket circuits within your house, and remember this is a socket here, called a ring mains. Okay, and the reason it's called a ring mains is because the sockets are arranged in a ring or closed loop. Look at this. There it goes, all the way around the outside, all the way around the outside in a big loop or ring. Okay, happy with that? I wouldn't colour it in, I'd just be aware of that now. And all the sockets come off that main ring. Now we're going to plug in this hairdryer. Plug it in here with a 3-pin plug. There we go, in she goes. Now then, once the hairdryer has been plugged in, we go from the consumer unit, which is down here, and we go along the brown wire. It doesn't matter which one I take, it's the left or the right hand. I'll go left. Along it goes, along the current goes, up here, along here, along this brown wire, bypassing all these sockets because they're not on at the moment, then gets to here, flows round, flows through the appliance, and then it comes back again. Yeah, nice and easy. And then it flows back down the blue wire, the neutral wire, all the way back down to the consumer unit. And then because it's alternating current, it goes the opposite way, so it will flow this way, 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 and then back again. Okay, it's alternating. Now, this time I'd like you to draw this in. We've got current flowing through the brown wire, travelling in this direction, through the brown wire, and then towards the appliance. But for whatever reason, the appliance is faulty, and now some of the current has passed through the person to earth. This lady's got an electric shock. That is very dangerous indeed. Not all of the current goes through her. Can you see this is a thin line back now? Some of the current has to flow back to the consumer unit through the blue or neutral wire, bypassing this socket, and then moving down towards the consumer unit. I'm going to put some arrows in now showing its direction. And okay, so we got a situation now where there's still current going through that individual. They're getting an electric shock. So how can we try and help this person? Well, we've got miniature circuit breakers which turn off a circuit if the current goes too high, but you can also have a residual current circuit breaker, or RCCB. I would definitely be using an RCCB when I am gardening. It's just like an extra socket. You put it into a normal plug. It can save your life. What happens is this RCCB, the residual current circuit breaker, monitors the current being drawn through the consumer unit via the live wire, and that round here is quite thick, isn't it? It's quite a lot of current. And it monitors the current returning to the unit via the blue wire. So it's monitoring a lot of current going out and a small amount of current coming back in. Why is that happening? Because some of the current is flowing through that person. If someone touches the live wire, a larger current will be drawn through the consumer unit, through the brown wire, than when it returns through the blue wire. The RCCB switches the circuit off and it reduces electrocution. I would definitely be writing or highlighting what I've done and highlighting the diagram here as well. Now, this ring main circuit, there it is again, and it's got all these sockets on it. Looks like on this ring main we've got 1, 2, 3, 4, 5, 6 sockets, and there's the consumer unit at the bottom. Now, what are the advantages? Brief notes, please. on ring main circuits. Sockets can be placed anywhere in the ring, so they can be moved around. Each socket has 230 volts and can be operated separately. So one of the sockets might be off and one of the sockets might be on. They work independently of each other. Each part of the cable carries less current, and the cables can therefore be made thinner. Remember, if I show you what I'm talking about here, the current can flow that way, or it can flow that way. And when it returns, it can flow this way or that way. Okay, moving on. Yeah, we've already had a look at residual current circuit breakers. They monitor the difference between live and neutral wires. They should be the same. The same amount of current should be going out as coming back in. If they're not, if there's a difference, this could occur if some of the current was lost to the ground when a gardener ran over the electric cables in his mower. RCCBs and MCBs work much faster than fuses and save lives. Just have a read through this final paragraph. All you need to remember is there are 3 wires in a socket. You've got a live wire, which is a brown one, a neutral wire, which is a blue one, and an earth wire. If there is a problem and current starts flowing through the earth wire, it doesn't normally, but if it does start flowing through the earth wire, then in the ring main circuit, it'll travel down the earth wire, and then it's going to go bump to earth. And so you can see that there's a metal spike that goes into the ground, and all of that current flows through the spike, bang, into the ground. And that helps to cause either the fuse to melt, or an RCCB or an MCB to switch the circuit off. It's a safety feature. That will be the end of this lesson.